All right, I'm going to run through the overhead masters for the binomial theorem that we looked at in class. So first of all, remember that binomial has two terms. So this is a binomial raised to the 0 power, which is always 1. This is x plus y to the first power, which is itself. And now here's where it starts getting a little messier, because when we square and cube and all this, we have to continue to do FOIL and FOIL and FOIL until we get these. But what I want you to see is some patterns that arise. First of all, one thing you might notice is the number of terms is always one more than the number you see here. Also, the first term is going to have that same exponent, and then it's going to go down by 1. So I've got x to the fourth, x to the third, x to the second, x to the first, and this would be x to the 0, which is just 1, so we don't even have to write it. The other thing you might notice is that the y is reversed in its order. So the last term would have y to the fourth, then y to the third, then y to the second, then y to the first, then y to the 0, which is just 1. So again, that doesn't show up. Something else to note is that the coefficients, the first coefficient is 1, the last coefficient is 1, and there's a symmetry that you see: 5, 10, 10, 5, 4, 6, 4, 3, 3. So there's a symmetry that happens. So let's take a look at that a little bit closer. The binomial theorem says that if you have x plus y raised to a power, so here's that first x to the n, and those are going to go down by 1. The y's are going to have the nth power at the end, and they're going to go down by 1 when we reverse it. And the coefficient is this weird notation. It's NCR, and it's defined by n factorial over n minus r factorial, r factorial. And sometimes this is written as n choose r over here. So NCR, this is also NCR, but it's just a different notation. Okay, one thing to notice is that the value of r is 1 less than the number of the term. So like if r is 7, that means I'm on the 8th term. So r is always going to lag behind by 1. So let's look here at how you would evaluate one of those notations here. So this is 10C5. So the way that works, according to the definition, is you put the 10 factorial, whatever this number is, you put that factorial on top. You also put this factorial on the bottom, and then subtract these two numbers and put that factorial on the bottom as well. And you can calculate this using the factorial button on your calculator, or you could expand it out and do it by hand. Okay, let's look at another one. This one is 8C2, 8 choose 2. So again, it doesn't matter the notation. This is the top number in a factorial. This is the bottom number in a factorial, but then you subtract these and put that factorial there as well. If it's in this notation, same thing. The 12 factorial goes on top, the 4 factorial goes on the bottom, and then subtract these and put 8 factorial on the bottom as well. Now just a note here with a couple of these, if you have the same number here and here, it's the same type of thing: 7 factorial, 7 factorial, and now subtract and you get 0 factorial, which by definition is 1, and this turns out to be 1. And then 6C0, it's similar, it turns out to be 1. So we'll look at these a little closer in a couple minutes. On your calculator, you can find an NCR option by going to the Math menu, and then you're going to hit the right arrow until you get to the PRB. If it's a TI-84C calculator, then it would actually say PROB, but then you're going to choose NCR. So you type in your N number, then you get the NCR on your screen, and then depending on your calculator, you will either just enter the R number on your main screen, or if you have the little boxes, so let me show you that. So you might have the boxes like this, and then the C, and then the box like this, where you would use your arrows and your number keys to fill in these two numbers. If you're looking at an TI-83, then you're going to put your number you know, like looking at this one, you would put your 10, then you would put the NCR button, and then you would put the 5, and then hit enter. Okay, so we'll move on here. So remember this one that we had on that original screen when we talked about how if this is a 5, the x's go down by 5, and the y here would go down by 5s in the reverse order. Notice that each of these shows up twice. The 5s show up twice, the 1s show up twice because there's symmetry there. So here's the deal. If these two numbers add up to 12, which is the top number, I'm going to get the same number here, and let me show you why. So for this one, I would have 12 factorial over 5 factorial, and then I would subtract and get 7 factorial. For this one, I would have 12 factorial over 7 factorial, and then I would subtract and get 5 and put a 5 factorial. It's the exact same problem for both of those. Okay, so now let's look at what's called Pascal's Triangle. Pascal was a famous mathematician that created this triangle, and what he did was he started with a 1, and he always started each row with a 1, and he ended each row with a 1. But for these numbers, he would add the numbers above. So let me show you how that works. So 1 plus 1 is 2. 1 plus 2, 2 plus 1. That's where the 3 comes. And the next one, we start with a 1, then we add, we add, we add, and we end with a 1. Next row, I start with a 1, and then I add the 1 and the 4 to get 5, the 4 and the 6 to get 10, the 6 and the 4 to get 10, and the 4 and the 1 to get 10, and so forth. So let me just get that out of there because we might need to refer back to that later. Here, you can either use this to find your coefficients. So this would be the 0 to the 0 power to the 1 power squared, cubed, and so forth. For example, if you are doing something like, let's say x plus y to the 5th, you know you're going to need 6 terms. So come down here and find the row that has 6 terms. That would be this one right here. Those would be the coefficients for your 6 terms. Let's go over here. And what happens here, notice that when I square or to the first, second, third, these are binomials that are raised to powers. And I would like you to notice that these numbers, the coefficients, are the exact same numbers that we saw in Pascal's triangle. So we call the top row the 0th row because it is x plus y to the 0. So this would be the first row, second row, third row, fourth row, and so forth. So let's look at, hang on a second. Yeah, let's move on. We're doing, so not going triangle here. So let's look here at the 8th row of Pascal's triangle. So this is the 7th row. This is the 8th row. Okay, so now remember we said if this is an 8, I would have 9 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, you can use Pascal's triangle to find the coefficients that we will use for this, or if you remember back on the very first screen, it had that NCR number. That's this. So this is, because this is an 8, this is an 8C0, 8C1, 8C2, and so forth. So when I look at the terms, this is actually the first term, second term, third term, fourth term, fifth term. Notice how this number right here is lagging behind the number of the term by 1. That's just something to kind of keep in mind. So the bottom line is, for back to this spot right here, this is the row that corresponds to, this is the 8th row, and it corresponds to 8C0 and so forth. So you have a choice. You can either use Pascal's triangle or you can calculate these separately. So remember again, just picking one of these out, this would be 8 factorial over 5 factorial, and then subtract the 8 and the 3, the 8 and the 5 and get 3, and there's a 3 factorial there. So you can find any term that you want by using this function here or by using Pascal's triangle. So let's look at a few examples. And I think I'd like to walk through this without having it all done for you. So I'm going to just put that over there for a second, and I'm going to grab x plus 2 raised to the 4th. And this is how I would do it. I would say, okay, if that's a 4, I'm going to have 5 terms, because there's always one more term than this number indicates. Okay, then the first thing I would do is I'm going to look at my x, and this is going to be x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0. But in looking at this, anything to the 0 power is just 1, so I really can just leave that off because it's just a 1. Okay, then I'm going to look at the next one, which is a 2, and I'm going to reverse it. This is going to be 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and 2 to the 0. Okay, again, remember, anything to the 0 power is just 1, and 1 times anything is just itself. So if you want to, you could leave this term off. Okay, so now I need the coefficients. So I could do it this way. This is 4C0, 4C1, 4C2, 4C3, and 4C4. So I could calculate all of those, or I could go back to my triangle and look at the row that has 5 terms in it, which is this. This would be my 4th row if this starts with 0, 1, 2, 3, my 4th row. So 1, 4, 6, 4, 1. So I'm going to put those in. 1, 4, 6, 4, 1. And then it's just a matter of cleaning that up. So let me move this away, and let's clean that up. The first term is x to the 4th, plus I have 2 times 4, which is 8, x to the 3rd. Next term, I've got 2 squared, which is 4, times 6, which is 24, x to the 2nd. For the next one, I've got 2 cubed, which is 8, times 4 is 32, so plus 32x to the 1st, and then plus 2 to the 4th, which is 16. So that is what I get when I expand x plus 2 to the 4th. Okay, let's look at another one. Okay, for this one we're going to expand 3x plus 4, that binomial, to the 3rd power. So I'm going to move it over, and we're just going to do it by hand like we did before. Okay, 3x plus 4 raised to the 3rd. I know that I've got 4 terms. And I'm going to start by looking at the 3x. I know that that's got to be 3x to the 3rd, 3x to the 2nd, 3x to the 1st, and 3x to the 0, which I know is going to be 1. Then I'm going to look at the 4, and I can either go right to left or left to right. This time I'll just do it over here. This is 4 to the 0 power. Then this is 4 to the 1 power, 4 to the 2nd power, 4 to the 3rd power. And then for the coefficients, I'm going to look at my triangle. So I'm going to pull that over here. Oops. So let's look at our triangle. Because this is a 3, I need row 3, 0, 1, 2, 3, the one with 4 terms. It's 1, 3, 3, 1. So I go back up here and I put in a 1, a 3, a 3, and a 1. And then let's get that out of the way, and then I just clean it up. So I've got 4 to the 0, which is 1, but now I've got to take 3x cubed. Well, the 3 cubed is 27, and then I have the x cubed. So I've got 27x cubed. Next, I've got a 3 times a 4 times a 3 squared. So when I look at that, I got 9 times 4 is 36, times 3 is 108. So I've got 108 x squared, and so forth. So let's clean up the rest of them, and I'll write down what those are. So there you have the full problem worked out. Okay, I want to show you a couple variations. Notice in this one that there is a minus sign there. Well, if that's the case, then you need to think of this as x plus a -5, that binomial raised to the 4th. So what that means is, as you're putting your numbers in, we'll start with the x. We know we've got 5 terms, so if I start with the, here's the x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. Okay, then we move on to the -5, so it's a -5. It's -5 to the 0, to the 1, to the 2, to the 3, and to the 4. And then when I look at the coefficients from my triangle, that's going to be my 1, 4, 6, 4, 1. And then you can see on here as they are multiplied out, you'll notice that when I take -5 to the different powers, it's going to be 1, it's going to be negative, positive, negative, positive. Because when you raise a negative to an even number, it's positive. To an odd number, it's negative, which means when I clean it up, my signs are going to alternate. So that might happen if you have a negative here. Let's look at this one down here. This one has already has an exponent here, and it doesn't change anything. When I put my numbers out, I'm going to put an x squared to the 3rd, an x squared to the 2nd, an x squared to the 1st, and an x squared to the 0. What happens when you raise an exponent to an exponent is you multiply, and that becomes x to the 6th. This becomes x to the 4th. This becomes x to the 2nd, and then obviously anything to the 0 power is just 1. So just to keep in mind, whatever you have here or here is going to be taken to those different powers, whether they're going up or down, and you just have to be careful as you calculate them. Okay, here is a problem that says find the 6th term of k plus 2m to the 8th. Now one option is, since it's to the 8th, you know there are 9 terms. You could put your 9 blanks and go through that process that we've been going through, but I'm only asked for the 6th term. So let's look at this row that corresponds to the power of 8, and I want the 6th term. So 1, 2, 3, 4, 5, 6. I'm looking at the 6th term, which is this. Okay, so the coefficient is NCR, and in this case, N is 8 and R is 5. So for the 6th term, I'm going to have R is 5. So I would have known that even from here. If it was the 6th term, I would know that this number is a 5. So I can calculate it out using my calculator or doing the factorials by hand, doesn't matter, but this number is 56 whether you get it from calculating this or you get it from Pascal's Triangle. But that's my coefficient. Okay, so now I need to remember, was from that first slide. This is the definition of the binomial theorem. So notice my x's go down by 1, but the term here is what I want to look at. And so let's look at this. This is my formula. I need N and R to be able to finish calculating this. So for our problem, the N is 8. So this would be an 8. This is an 8, and this is an 8. And then as far as the r goes, my r number is 5, so this is a 5, and this would be a 5, so 8 minus 5, and this would be a 5. Now the other thing to remember is this is for x plus y, but my problem is k plus 2m. So down here I've kind of expanded it out. N is 8. We know that because of this right here, either from writing all of these out until I get to the 6th term, or we can just remember 8 is always the n number, and if I want the 6th term, this is going to lag behind by 1, so it's going to be a 5. So n is 8, r is 5, and instead of an x, we've got a k, so take out the x and put a k, and take out the y and put in a 2m. So I'm going to take this funny looking thing and I'm going to put in the 8 for the n's, the 5 for the r's, and k goes in place where the x was, and 2m goes where the y was. Now this 8c5 we already calculated, that's 56. So there's the 56. This is k to the 3rd, and this is 2m to the 5th. Well, 2 to the 5th is 32, and here's the m to the 5th, so it's 32m to the 5th. And when I multiply those out, so when I multiply the 56 by the 32, I'm going to get 1,792, and then I need my k cubed and my m to the 5th. And this would be the 6th term of that expansion. Okay, here's one last problem. Find the coefficient for this term in this expansion. Now, this is an 11, so I know I would have 12 terms if I wanted to put 12 blanks in. And I'd be looking at what term is this. So remember that this had to have come from this definition of the term. Now I know that n is 11 because this is an 11. So this number is 11, this is an 11, and this is an 11. So if this is an 11, 11 minus r, and this is r, and I've got a 5, and 11 minus r is 6, that tells me that my r number must be 5. So r is 5, and my n is 11. Okay, so when I fill these two numbers in over in my formula, I get 11c5, and now instead of an x, I've got a 3a. So that's why this is a 3a instead of an x. But 11 minus 5, I know that's going to be a 6, and this is going to be a 5. And again, this is a minus 2b, so this is a minus 2b instead of a y. So when I calculate this using my calculator, I get 462. And then I've got 3 to the 6th, which is 729. So this is 729 a to the 6th. And over here, when I take negative 2 to the 5th, negative 2 to the 5th is going to be negative 32, and then I have b to the 5th. So I've got negative 32b to the 5th, 729a to the 6th, and then this 462. And when I multiply the three numbers together, I get negative 10,777,536. I also have my a to the 6th and my b to the 5th. So the question was, what's the coefficient? This is the coefficient for that term.